All right, looks like we're good to get underway. I know that I'm the only thing standing between everyone and the after party, so I'll try and make this nice and quick. Welcome to React Beyond Redux. My name's Aaron Powell, and hopefully the next hour I'm going to teach you some other ways that we can look at the Redux framework. So, why are we here? Why are we talking about Redux without React? Well, Redux, it was a library that was created a couple of years ago by a guy named Dan Abramov, and he actually works for Facebook. I don't think he was working at Facebook at the time. He was just a React user. He now works at Facebook inside of the React team or the various teams that work on React pieces. He first demoed it at React Europe in 2015, and the premise was he was looking at an alternate way to do Flux. And that was one of the underpinning reasons for React is that he wanted something that, for Redux, he wanted something to work with a React application, but he wasn't quite a fan of the way Flux worked and some of the patterns that were involved in that. So he put together this really simple framework and demoed it off and demoed a bunch of really interesting things around how it would work inside of a React application. But today I want to talk about Redux when you're wanting to use it inside of a different application architecture, or maybe you're not using React, maybe you're using another JavaScript framework, because it turns out that Redux is actually not specifically tied to React. It just happens to be really popular inside of the React community. That's where the author and a lot of the contributors have come from. But it's not specific to Redux, to React. I'm going to keep saying React instead of Redux or Redux instead of React, and it's going to be really annoying throughout the rest of the talk because I'm just going to keep going back over my own words. But bear with me, there's only 58 minutes left to go. It'll be fine. We'll get there. So to get started, I'll just talk a bit about Redux for those that either are not familiar with it or haven't used it in any great depth. There's three core pieces to it. We have actions, reducers, and a store. This is kind of the iron triangle of a Redux architecture. You've got these three core components. Actions in Redux, this is something that has happened inside of the application that's using Redux. It's got a unique identifier on it, so it's commonly done with a type property on the object that's being passed as a Redux action. But basically, it's some kind of an event. Thinking about it from a .NET perspective, that's my background as a .NET developer, it has a lot of similarities to the kind of events that you would raise inside of a .NET application, be that a desktop application or a mobile application, or even server-side events inside of a web application. And what I've got here is a very simple action creator function. It's called echo action. It has an input to it, and it returns you an object, which is the actual representation of the action. You'll see that we have a type property here that has a value echo. So this is the action type that's being raised by our system. We have some kind of data that's being passed to it. In this case, I've got a payload property, which is the value that is to be echoed out. So the reducer. This is something that listens for actions or a single action. It receives the existing state of your application, so the state that's been produced based off any previous actions that have been executed, and it combines it with the current action to then produce new application state. So the idea of this is that it's a pure function. If you've done functional programming, the idea of a pure function is probably fairly well known to you, but at the end of the day, a pure function is something that receives all the input that it would need to be able to do something. It has no external dependencies in terms of global variables or global state outside of that function. And internally, it will not mutate anything that it doesn't own. So the state that's passed in doesn't change. You produce new state based off of that. So here's a reducer function. You see we've got two arguments that go to it. We have an action, we have the state, and we have an action. We then are doing a test here to work out if this particular reducer is capable of handling some kind of an action. So in this case, is this reducer able to handle the echo action? It does. So if it does, it returns the action payload, so from the previous slide. But it might not actually deal with there might be other actions that are being triggered within inside of our system that this reducer doesn't care about. It's got no ability to work with them. It doesn't need to do anything with them. So those will just return the current application state because we're not going to change it. So we're just going to it becomes a no-op operation essentially. So then, the store is kind of the cornerstone of your architecture. It's where everything lives. So it's the only place in your application that state would then mutate. So an action gets triggered, the reducer produces new state, the store knows about that, and then it has the state. It's the one that's updated based off of the new state that was produced by the reducer. It handles the marshalling of an action or multiple actions across to the reducers that are valid for them. So it will do that sort of that pass through. You can have middleware applied to it. So kind of if you're familiar with many of the web server approaches that are happening at the moment, be that ASP.NET Core, be that Web API on top of Katana, be that Express or any of the other Node.js ones, middleware is the idea of being able to just plug into a pipeline and have something executed at some point in time before the final part of it. So we receive something, we do something with it, and then we pass that on to the next stage of our pipeline. So that middleware is handled entirely within inside of your store. And the final thing it does is it has to tell people that the action has happened and that state has changed. It'd be all well and good if it just internally updated state and then no one knew about it. Your application's not going to do anything. Like, how does the UI respond to data changes if you're not able to tell it? So that's what subscriber notifications are all about with inside of a store. So the store actually is created from a function that comes from Redux itself. So this is the first time that we've actually had something provided by the Redux library. Everything else has been kind of ceremonies around how Redux would work. And it's a method called createStore. It receives up to 3 arguments. In this case, I'm passing in just 2 arguments. The first argument is the reducer that this store uses. We pass in some initial state of the application. So in this case, the initial state is empty string because we're just going to echo out things that get dispatched to it. The third argument would be if you're using middleware. Obviously, for this trivial example, I'm not using middleware. You see, after we've created the store, we're then subscribing to change events. We pass a delegate function to it, and this will be triggered every time an action is dispatched. This one is just really obviously simple. It's updating a UI in the form of a DevTool console. So when the application, when action dispatches, console.log will eventually get executed with the state of the current application. And down the bottom there, we're triggering off a new action. So the system has done something. The event has fired. We're invoking the echo action. So there's some interesting quirks about the way the Redux architecture works. So an action needs to have a type, as I said before. Now, this is a little bit problematic inside of JavaScript because we need some way of being able to identify different kinds of actions in JavaScript because we have a very simplistic type system. The easiest way to do that is just a property on the object that we're passing around, the type property that we saw before. Reducers, they can't change the state that they're given. So your state could be really large. You could have 10s, 20, 100 properties on it. And you're getting to 100 properties on your state. You've probably got some other architectural decisions you need to think about. But with all of that data, you need to then build an entirely new object based off of that. Reducers can't return undefined. Your application should never get to a point where the state of the application is undefined. If your application doesn't have a defined state, well, what is your application actually trying to represent? And everything that happens inside of a store happens synchronously. So when you dispatch an action, it goes straight through to the reducer. It might pass through middleware, sure, but everything happens synchronously. Now, this is interesting in JavaScript if you're doing something that is asynchronous. A lot of what we do in JavaScript programming is asynchronous. We're using fetch to go out and pull something down, or $Ajax if we're using jQuery. That's an asynchronous operation. And this is where middleware starts playing in. You would have a middleware that can handle something that's asynchronous, turn an asynchronous operation into several synchronous operations. We've started an Ajax call, we've finished an Ajax call, and our application then can respond differently to those. We're starting an Ajax call, we show a spinner to indicate a loading state, Ajax call finishes, we hide a spinner, that sort of thing. Now, you might be thinking that you've heard this kind of an architecture before. Well, it's not a Unix system. But it's basically an event store. This architecture is very common across a lot of different programming languages and a lot of different design paradigms. The idea that you have a single place where data lives and that owns state as it is. Like I said, it's basically an event store. So congratulations to the JavaScript community. You have rediscovered something that we've been doing a long time, particularly in server-side programming. Well done. And of course, being JavaScript, we had to give it a funky name so that everyone knows that we did it first, and it's awesome. So, Redux in a nutshell, that is. Now, I said the premise of this talk is we want to look at Redux beyond React. So, with Redux, the create store is kind of the core thing that you would work with, and then you need some way to plug it into whichever UI framework that you're working with. There's actually bindings out there already for non-React frameworks, so things like Angular 1, Angular 2, and Angular 7, which I think got announced yesterday. Versioning is hard, but I think they're up to 12. There's things like Backbone. There's bindings for that. I've seen bindings for Polymer. And kind of pick your big popular UI JavaScript framework, and there's probably a Redux binding for it out there. Or you could create something for a less popular framework. You could, and it's actually fairly trivial to create bindings. So that's what I've gone and done. I've created a bindings for a very, well, I'm not going to say unpopular, but a less than popular or less than common framework. So I'm just going to open up Visual Studio Code. And who remembers Knockout.js? Yeah, we got someone over here that remembers Knockout.js. Now, I'm going to admit that it's quite a few years since I've written anything with Knockout, but I thought this was a good illustration of how it doesn't need to be used with any particularly fancy JavaScript framework. Nothing that has massive ceremonies around it like you get with Angular or Polymer or React or anything like that. I'm just going to start up some code, launch up our browser. So the idea, I click a button and a counter goes up. Excellent. Code demo has succeeded while I'm clicking on the button, and this is a highly technically complex application that I've got right here. So I have an action defined up on line 28. It receives a value. It has a type of increment, or inc, payload, which is the value, and then that gets passed through. We have a reducer, which I have defined with some initial state there. It has the number of clicks that are in there, which starts off as 0. Unsurprisingly. And then the action, if the action was increment, then we create a new object based off of the existing state. Now, admittedly, the existing state is probably only ever going to have that number of clicks property, but if it didn't have the number of clicks property, I'm using object assign on line 37. Object assign is a very simple way to create new objects based off of other objects and then override properties on them. So I have an empty object, which is the first argument. I have an object, which is state, and then I'm passing another object, which is going to override. So the number of clicks property would override the number of clicks property on state, which would override the number of clicks property on the empty object. So that's how we would build up a new object based off of an existing object. Now, we've got Redux create store with our reducer. I'm not passing in default state because I'm using a default argument instead in our reducer, just kind of illustrating different ways that you can do that. And now we need to bind this to the UI. I want to take my store and subscribe to the events that are happening with it, the dispatches that happen, and then push those up to the UI. So when that happens, I'm going to unpack the state. And this is a common way that you would work with React and Redux together. You have a method that the bindings give you called connect. You connect a Redux store to a React element, and you do that by mapping the state of the store to the properties that get passed in. So I've just kind of used some common naming that you might come across if you've looked at existing Redux and React tutorials. But the thing is that I've written this for Knockout.js, so it works slightly differently. So I have our store, dispatch to props and state to props, and that takes, so the first one takes the existing state and then returns a new object based off of that. Doesn't really provide any particular value, but it still works. And then dispatch just produces a click method that, with my knockout binding, I can bind up here at the top. So how does this work internally? I have a Knockout.js view model. Not particularly complex, doesn't really do a whole lot of things other than It has an observable property that has an initial state passed into it. It has a method called register click that when you click on that, it triggers the dispatch on the store, which is what happens there on in line 57. You create that method. So I created some bindings for Redux to React. We have a connect method that receives the store. It then returns you a new function that you pass in dispatch to props and state to props, which then returns you a new function that you pass in the view model. The reason why you would do something like this is you might want to connect one store to multiple view models. So I could pass in, first off, you might want to take one store and remap the data within inside of that store differently depending on which UI. So you might have a different implementation of the state to props method, for example. So we could be unpacking that slightly differently. Now, so I could invoke, back onto here. So I could invoke redux.ko.connect store and then use that multiple times, just cache that as an object. I could execute up to these two lines, and then pass that with multiple different view models in Knockout, so that I could use the same underpinning set of data, but render that differently based off of the needs of a particular part of my application. And then the final thing is I'm passing in the view model so that gets done. We create an instance of the view model, we give it the initial state of the application, and then I subscribe to the store change. So every time dispatch happens, we subscribe to that, and we unpack state on line 18. We then create the new properties by using the state to props and dispatch to props, so unpacking the new application state. And then I go over the view model, find all of the observable properties of that view model, and then update them based off of the store. Sorry, based off of the application state. So that's what's happening on line 26 down. So we kind of hide away all this stuff about updating multiple sections of the UI, and if I had a more complex view model, I might have more observables on there and more parts of state that I could be mapping back and forth. And that's how kind of simple it would be to plug this into just a different kind of UI framework. In this case, I picked something like Knockout.js, but that's the underlying premise. You might have something that you've internally written inside of your company that has the same sort of analogous components, which is view models that you want to be able to update, and that's a very simple way that you could use Redux with a different UI framework that doesn't have existing bindings. Now, Redux actually works quite nicely with something like Angular. It helps you move away from the idea of having $scope everywhere within inside of your application. If you've got a controller and then you've got multiple, say, nested directives underneath of that, and you want to pass data down and then you've got to pass data back up from the directives, you rely on things like broadcasts and watches to do all that, and those can have some performance impacts. So being able to do everything as one-way data binding, push it down, and then just push down dispatch methods that you can invoke, that then updates the controller, and then it just pushes data back down. That can really simplify the way that you can understand how data is flowing throughout an application. All right, so Redux is actually pretty simple, it turns out. Oops, wrong button. There's only really three core concepts to it. You have create store, which is the one that you would use most frequently. Without creating the store, you're not really doing a whole lot with Redux. It has the ability to create middleware, combine multiple functions together to produce a chain of middleware that would be executed. It also has the ability to take multiple reducers and combine them together to then allow you to pass actions to that as though that it was a single reducer, and it handles the passing that across to multiple different, to the appropriate reducer. It's mostly about the architecture is how things will interact with Redux itself. It describes how an action should look and how you provide that into a reducer. That kind of stuff is what is really what the core of Redux is. So it can easily be translated elsewhere beyond React. So it turns out that Redux itself is actually a really small library. It's got slightly bigger over time as smarter people have worked out better ways to do parts of the architecture. They've continually optimized that sort of stuff. But at its core, it's really quite simple. So a little while ago, I had an idea that I wanted to learn how Redux worked a lot better. So I decided to create a library called Redux. Pause for dramatic effect on the humor, and continue on. I created a library called Redux to use as a learning experience for myself and to share, hopefully to share with others about how the internals of this works. So let's just have a look at that and have a look at a way that we can use that in a different application style. Yes, terminate the task. Oops, close that one down. So I'm just going to open up a different tab, and we'll open up VS Code here. So this is a implementation of Redux that it works pretty much the same as Redux, and that's going to get really properly confusing for everyone. But my implementation, the quacky one, it doesn't have all of the validation checking internally that the actual implementation does, but it does most of the same things. And I created a demo application that we can use with this, so I will just run that, Redux-demo. And this time, I decided to create a console application. Again, just to kind of illustrate how this application architecture is not specific for web UI implementations of Redux and UIs. So I have some application state. I've created a to-do application because so far at NDC I have not demoed a to-do application, so at some point in time I needed to do that because it's the only way that you can really illustrate complex software problems is with to-do. So we've got a couple of different actions that our system could dispatch. Dispatch added to-do, dispatch that marking all the ones as done, and changing the visibility. So we'll dispatch to-do, which is write a talk, and then we'll add another one, be awesome. Now I've got some additional actions that I could be dispatching. So I could find this one. I'm pretty sure I've written the talk. I can just click on it or interact with it, which dispatches an action that has then removed it from the list, marked it as done. So if I toggle visibility and dispatch a different action, we get a different state. We're seeing a different representation of state within inside of our application based off of the action that we've dispatched. Toggle them back. I can mark all as done. And, whoops, quit. So this is reasonably simplistic internally. I've done it in a way that I can use Redux or I can use Redux. Work out which one was which in that statement, because I'm not sure either. But similar things that we've seen in a couple of demos and things I've talked about so far. We create stores, we subscribe to state. This time, because it's a console application UI, we're using console.log to write to the UI, and a couple of different ways that we can do colors within the side of that, so like errors and things like that. We build up a series of prompts which gives us a bunch of a bunch of actions that can be dispatched. So we're dispatching those against the store using action creators. All that's fairly simple. So let's have a look at the create store method. As I said, this is really the cornerstone of working with React. Is you need to have a create store method. Sorry, Redux, because you need to have a create store method. Without creating the store, you're not creating anything with Redux. Bit of null checking, a bit of type checking at the top of the function. We then have our state, which, as I said, that's the only part of the application that's mutable. We have subscribers that are going to be listening to dispatches getting done, and at the end of the day, there's some stuff that I'm not going to talk about inside of here, just because essence of time, and it's not particularly interesting. If we have enhancers, so enhancers are just the terminology for middleware that I used when I was copying and pasting code or reading the source code of Redux, that they use the term enhancers, but essentially that's middleware. We'll talk about that in just a moment. The subscribe method is kind of interesting. This wasn't something that I noticed until I really dived into the source code, is that when you subscribe a function to a store, it returns you a function which is the unsubscribe method. So you might be, from a memory management perspective, particularly if you're working with a console application, you might want to unsubscribe when something has been removed from state. When you marked a to-do as done, you might be actually removing that instead of just hiding and showing it like I was doing. So you want to remove some kind of an event listener against that thing. So you could be calling the unsubscribe method. So it returns you something that you can actually use as the dispose. Also, what it does is when the subscribers are executed, so the dispatch method is then the kind of really cornerstone piece of making. I've said cornerstone like 10 times. I'm sorry. It's the brains of it. So this is where you pass in the action. It checks to make sure that you've provided a type of the action so that we know what we're dispatching. We'll then pass that across to the reducer with the current application state. And here's where mutation happens on line 49. You'll see that we're updating existing state. And that's the only place that should ever happen with inside of your architecture. We then go through the subscriptions, execute each of those just so, hey, anyone that's listening, data is updated. The very last thing that this does on line 62 is it dispatches an initialization action that you really shouldn't be listening to if you read the Redux docs, but it's done by their implementation, so I did it. I can't think of a decent reason as to why it's being done. They just say it's a complete anti-pattern to ever listen to that action. It's really difficult to listen to that action because you can't subscribe until after you've created the store, but as soon as you create the store, it dispatches that action. So it's a chicken and egg problem. You can't really ever actually listen to it because it's fired before you could ever subscribe. But it's there, they do it, so I had to do it as well. Now middleware is quite interesting because, like I said, up here on line 14, we invoke the enhancer and we actually pass through create store. You can see here, so that actually passes a reference through to this function followed by the reducer initial state that we had up top. So the way that works is we have the collection of middlewares that we're going to have inside of our application. We receive create store with the reducer and state, and it then actually invokes that. So we've gone from this file, we've gone to create store, we've then realized we've got middleware, we've then gone over to middleware, which has then gone back to create store. But this time we've dropped off the middleware here, so it actually just creates the store as though there is no middleware. It will then grab the dispatch method and then walk through all the middleware and wrap a function around them that eventually will call dispatch. So it basically builds this chain with a next function, and the next function either points to middleware or to dispatch. So it's essentially a loop that is executed, and as long as you keep calling next, you'll eventually dispatch an action. So that's how kind of Redux works internally. And this is how you could take Redux and not use it inside of a JavaScript web UI. So, observing Redux stores. Now, we've used the subscribe method so far. We've seen how that can be used either a console application or it could be used inside of a web UI to listen to events that are happening and changes that are being done and things like that. But it turns out that a Redux store is actually an observable object. So under the covers, it also implements symbol.observable, which is part of ES 2015, I think that was when the symbol was introduced. I don't think it was 2017. Pretty sure it was 2015. And so under the covers, what that gives us is it starts to look and operate a bit like a stream. Or it allows you to combine it with something like RxJS. And if you've done stream-based programming and observable-based programming in the browser, Rx is probably the most common way you would go about it. It's the simplest way to get started. So what that means is that we could take a stream and we can listen to that in different ways. We could do some sort of subscription to that applies a filter. It does a conditional subscription to that. And that's executing. It's kind of like middleware, but after the action has been done, after the reducer is fired, we might want to do something different to that, to what's happened at the end of the day. So we can listen to that and produce a conditional subscription. We could remap the data after the state has changed. So after something like convert state to props has been invoked, we can then remap that to create an entirely new data based off of that stream. Or we could combine it with another stream. So say that you're listening to a WebSocket, and the WebSocket is just pushing data out that you need to display. Stock ticker is a classic example of that. It's firing data down to the UI. Now, you don't want that inside of a Redux store because this is really fast-changing data. It's really continuously incoming data, and you might want to be doing some processing on that. Do we need to slice out of it? Do we want to put some kind of a buffer so that we only get data every 5 seconds, even though the server is pumping it out every single second? That kind of stuff. We can combine multiple observable streams, one of which happens to be a Redux store. So let's have a look at how that one would work. Back to VS Code and open up another demo. Cool. All right, so let's run this one in Chrome. Apparently Chrome crashed. Awesome. All right, so I wrote a clock. This clock, actually, let's just font size that a touch. So the clock is showing minutes and hours on it, and underneath, just to show that there is continual data being pumped to the UI, it's showing the seconds as well. That's ticking over continuously. And every minute, the minute hand will tick. Well, at least in theory, and that seems logical that the minute hand changes at least once a minute. So I've only got 23 seconds left that I have to keep talking to make sure that this demo continues to work. But the fundamental thing that I wanted to show here is that this is the same underlying store, and I can do different things to that to render out the UI. I don't want to continuously be checking with inside of my SVG going, no, I actually don't want to show I'm not showing a second hand, so you don't have to do anything. I actually want that element completely ignored until the minute has passed. And there we go. It should have moved, but I was probably talking, so you didn't even notice. Damn. So how does this look if we scroll down? Reducer, I just have the ability to stop and start time. Yeah. Oh man, my jokes, is it too late in the day for like really terrible dad humor? I think it must be. We have an action that could be fired that tells us to draw the clock. So when the system first starts up. The reason this is kind of where I realized that you couldn't use the init method. You couldn't, the init action. You couldn't subscribe to that. I was like, I wanted to just subscribe to that because the store's created. I want to be doing something. Oh no, it turns out you can't because that action doesn't. You can't subscribe to that action having been fired. Then we have another action type when time has changed. Now we're no longer drawing the clock because otherwise we'd just continue drawing the clock on every second and we'd end up with a lot of clocks. But we have the previous tick or previous second and the current second, and that's just so I can work out whether or not to change the minute hand. I have the Redux DevTools enabled here, so that's an example of using middleware. I'm subscribing to the store, just plain old subscribing to the store, and every single time an action is dispatched, I will check to see if there is a time component associated with that, and if there is, update an element just using moment for some formatting that displays the hours, minutes, and seconds. I just realized, oh no, I was like, is it actually 6 p.m.? Yes, it is 6 p.m. Wow. Moving on from that one. After we've created that one, so like I said, that's firing continuously. That subscribe is continuously happening. On line 62, I'm using Rx observable from and passing it an instance of that store. Now, this is Rx version 5, not Rx version 4, which is what I found out when running this demo, and it took me probably an hour to work out why my store wasn't being, why I was getting errors trying to subscribe to the store, and because it's just you can, it's an observable, just use Rx. So I go to reactive extensions and I download Rx and it's not working. And then I go back and I read and it's like use Rx from Rx/RxJS, not Rx extensions.js. It's like, thank you for making that horribly confusing. But still, we can turn our store into an observable. And then on 64, I've got an example of using filter. So this is a conditional state change. So if the state is if the state draw clock is true, then we'll subscribe and we'll pass through and we'll invoke the draw clock method. So this will only happen once, obviously, because that's the only time that action is ever fired. I have then a couple of other observables that I'm doing. So I'm observing while there is while there isn't a previous and there is a current time, then we'll update the clock with the current time. So while there is previous and there is current time, we'll update the clock. And then I just wanted to use an example of you could chain multiple filters together. So if you had multiple things that could be conditionals as to why you would be interested in state changes happening here, we're filtering as long as there is a previous time, and the previous time minutes is not equal to the current time minutes, then I'm going to use map, so unpack that state object even further. And then we're going to update the clock, so redraw the minute hands. I just realized that those two are basically the same, so I'm actually updating the clock twice. Oh well, moving on. And then at the bottom I have a button to stop and start the clock, which just clears intervals and things like that, because I'm using a set interval to do the continuous running. So that's an illustration of using observable streams to then combine that with a Redux store to make an observable UI. Okay, so step back forward through my slides. All right, now we've kind of seen how this all works with inside of JavaScript. And I really wanted to challenge myself when I was putting together the idea of this talk about how could we use Redux even further than just kind of JavaScript UIs and either that console application versus a browser-based application. So I thought, well, what if we wanted to try and using Redux without even using JavaScript? So I set myself a challenge to implement Redux in Fsharp. Why? Because I just felt like writing something even more complex than just a C# implementation. Also, it turns out that someone had already written a C# implementation of Redux. And if you were in my talk yesterday morning about bad ideas, you would see that just because someone's done it doesn't mean you shouldn't do it anyway. So that's what I did. I have written an implementation of Redux in Fsharp. And also, this gives me a chance to talk about Fsharp, and I just like doing that. And sorry to anyone that doesn't like Fsharp, but you're going to sit through at least a couple of minutes of that. So let's open up this file, and we'll marvel in the joys of angle brackets and no semicolons and type inference. So we have a couple of types that are defined, and generics in Fsharp are fun and interesting and give you all sorts of pain. But the important thing here is we have a store, which has state and payload as generic arguments. Now, this is where it starts getting interesting. Think about Redux on a compiled language. So it could be C#, it could be Fsharp, it could be any other, it could be TypeScript even. A compile-to language for JavaScript, or a non-browser-based compile language. Because a Redux action has to have some kind of a type, and we do that in JavaScript with the type property, well, if we've got an actual type system, well, that makes things even easier, doesn't it? That's one less property that we have to worry about. Advantages of type systems right there. So we have getState, we have dispatch, and we have a subscribe method. So, apologies to anyone that is either not familiar enough with Fsharp. I'm going to not particularly dive into the syntax here. I will try and cover off things that are relevant to understanding what's happening, but there is obviously a lot of arrows and things like that in weird locations that might not be familiar if you're not an Fsharp user. We have a method that builds up our middleware and builds up that thing where we dispatch and then executes the middleware in sequence to finally dispatch an action. But the create store is the really important thing that we have at the end of the day. Now, remember from our JavaScript implementation that if we have middleware, we then need to re-execute create store, but without the middleware, and then we do some stuff to it after the fact. Well, to do that in Fsharp, we need to create a recursive function. So in Fsharp, we have a rec keyword that tells it this function is going to be recursive. That's so the compiler understands it's a recursive function and can do some optimizations. We then have a function that takes a reducer. It has some initial state passed to it, and then we have a sequence of middlewares that pass to it. Because this is about 100 characters of type definition, I've created a type on line 12 to represent that. But it's a sequence of middleware functions that would be executed. Now, if we have been provided with some middleware, then, the first thing we do is we've got like a switch sort of statement, a match statement in Fsharp. If we receive middleware, if we don't receive middleware, then we call create store with the initial state and no, that's if there is middleware. Sorry, it is empty is false. So if there is middleware, we then re-execute create store, but without the middleware. We then grab the dispatch method. We then build up our middleware chain and so on and so forth. And then we return the store at the bottom. If there wasn't middleware provided, we get the initial state. And you'll see that this is mutable because state can only be changed within inside of the state. Within of the store. And in Fsharp, everything is immutable by default. So we have to explicitly make this mutable, which is kind of a really good way to think about mutability and immutability inside of a Redux store. Is you kind of have to be forced into choosing what you can and can't change. We have our subscriptions, which is a mutable collection because you can add and remove subscriptions. We have a dispatch function, which will invoke the reducer, take state with the state and the action, and then update the existing state. We have our subscribers that we'll then iterate over and execute, and then we return the action just because that's how Redux works internally. We have subscribers, which subscribe methods, and then we return a store at the end of the day. So, how would we use this in a server-side application? Well, I was trying to think of it. It was all kind of well and good to write an implementation of Redux that should theoretically work and write it in Fsharp, but what was I going to do with it? It lives on a server. The point of Redux is that it's for doing a stateful application. I'm a web developer, so the idea of a stateful application in .NET that's living on the server, well, that is not. You don't do that with the web. The web is stateless. So how would you do this? Well, WebSockets. I decided to go with WebSockets. And what do you do with WebSockets? You create a chat application because it's the most useful thing that you can do with a WebSocket server. So I cracked out Signaler. I have a Signaler server running in the browser. Signaler server running on the server. Signaler clients running in the browser. They'll connect. When they're connected, they subscribe to changes that are going to happen inside of the store. So state entirely lives on the server, and every time a dispatch action happens, we will then notify the subscriber, so actually push something down via the WebSockets. And this is where we can start seeing the advantage of a type system with Redux. I have the payload, which is the action that's being dispatched. I no longer need to have a type. I can just have a payload, and then based off of the type that it is it someone typing? Is it a new user has joined the chat system? Has the user posted a message? So you typing, so John is typing, a user has joined, John has joined the chat, post message, someone has hit enter to actually send a message over the chat system. So that then would come in to the way that we're using Redux. And this should hopefully be making me starting to sound like a broken record. We have a reducer. It receives state and actions and all those sorts of things. But instead of having to do if action.type, we can use a match statement, which if it's a message, if it's a new user, if it's a typing action that's been dispatched, we do different things. We create new state based off of the existing state and change the parts of it that particular action should change. So when a new user, on line 26, when a new user joins, we take the existing state of the application, but we update the users by adding the user who has just joined. I've also got an example of how middleware works. When a new user has joined, it will just do a console.write line, essentially. If the action that was dispatched is not new user, then we just perform a no-op. We create our store, and then that should all be up and running. So let's run this and, wait, did I hit F5? Let's hit F5 again. Come on, demos. Let me just check my Solution Explorer, and I have the wrong project set as the startup project. let's change that. F5, and we'll start up our SignalR server. Now, remember that state entirely lives on the server. The browsers are just essentially taking messages that are being sent to them and displaying them, or they're going to display them in a UI. So we'll come into our browser and we'll go localhost 8888, and I will join the chat. And then let's duplicate this tab, and John can join. And let's just pop these side by side so we can see. Bit of font size. So, hello, John. Send, and we can send messages back and forth. And John can type something. Now, this is entirely living on the server. So if I was to reload this tab, and this can be James, we get the existing state of the application because state is not inside the browser. The state is elsewhere. This also then opens up for some really interesting quirks of it. If someone joins again as Aaron, let's just pop that one down here, and we'll start typing in there saying, hey guys, and single shared state. You'll see that both Aarons are now typing. And we send the message, and now we've updated state, but everyone sees the same thing, but shared state. Something to be mindful of, though, if you're doing this inside of an application. Now, obviously, this is a fairly trivial example and a fairly silly example of what you might be using a server-side implementation or a .NET implementation of Redux. But a more realistic scenario for this would be a mobile application. Mobile applications are single user, generally speaking. They're going to have some kind of data that lives within inside of them. You're going to have actions that happen when you interact with those that you need to change data within inside of that application, send it around, maybe update different parts of the UI. Ecom application is a good example. You click add to cart. We need to update the cart in the the top of the application. We need to change the amount within inside of our cart costing. All those kinds of things. So this is where I get back to talking about it's events. We're triggering events within inside of our system. So that could be a non-JavaScript usage of Redux, and this is why. This is how I came across that there was a C# implementation of Redux. So, like I said, I'm well aware that I'm the only thing standing between everyone and the after party, so hopefully your minds are blown with the possibilities of how you can use Redux and not just have to use it within inside of a React code base. You don't even have to use it within inside of a browser. You don't even have to use it within inside of a JavaScript application. It's a very simple pattern. It's really just it's an eventing system, an event store kind of system underneath that it can be very quickly written in whatever programming language for whatever application architecture that you're working with and whatever application target platform you're working with, be it web, be it desktop, be it console, be it mobile. Thank you. Any questions? If not, I believe there is a party happening outside. Or if not, we are going to go start a party happening outside. I'll obviously be around as well if you want to ask me questions or say why would you do any of this in Fsharp. I'm more than happy to answer those questions. Thanks, everyone.